Good evening, students. Mushti sir again. We will going to discuss the lecture 3 of this difference between EMF and potential difference in EMI. Okay. Already I have discussed VDL 110 and 111. This EMF and potential difference. Now I am going to discuss a very crucial point here. Okay. What I am discussing a case of a conducting ring placed in a time-varying magnetic field. A homogeneous uniform conducting ring is placed coaxially in a uniform time-varying magnetic field existing in a cylindrical region. Find out the potential difference between 2 points on the ring subtending an angle theta at the center. Is there any electrostatic field in the ring or not? So in the diagram you can see this is B pointing into the plane. dB by dt positive means increasing. If it is increasing, then non-conservative electric field will appear in anti-clockwise manner. You must have seen earlier our lectures. Okay, so refer to my previous video lecture VDL 110 and 111 to calculate the EMF induced in the arc PQ. What should I do? I join P and Q to the center. See the closed loop area, that is sector closed loop, that is half A square theta into dB by dt. So this EMF will be loop EMF will be equal to PQ EMF in PQ. Why? Because OP and OQ there will not be any EMF induced. ENC, and this is the DL is perpendicular to DL is radial, ENC tangential, ENC, and this is the DL. DL is, I can show you just like this, the DL. This is the DL. As you see, ENC and DL are mutually perpendicular every point of OP and OQ. So no EMF from O to P or Q to O. So the EMF in this loop, OPQO loop, is equal to EMF in PQ. That's what I discussed very clearly in VDL 110. I have written that. So total EMF in the EMF in the PQ will be d flux by dt in the OPQ sector. So that is half A square theta dB by dt. Half A square radius is a half A square theta is the area into dB by dt is the EMF in the loop, and that is EMF in PQ. Total EMF in the ring is pi S square total area into dB by dt. Very good. Resistance of the ring be capital R. So resistance of the arc कितना होगा बाबू? The total length का resistance, total circumference का resistance R. So ये arc का resistance कितना होगा? Proportional to the length, because everything else is same cross section, same material. So PQ RPQ will be theta by 2 pi into capital R. That's it. So current I in the ring will be how much? Total EMF in the ring divided by total resistance R. That's what I wrote. Now start from P and travel towards Q. Start from P, travels towards Q. So Vp plus EMF from P to Q minus I into R of P and Q is equal to Vq. You must go from basic current electricity. Vp plus EMF from P to Q, that is all the battery potential from P to Q minus I into RPQ is Vq. Clear? So substitute the values EPQ I have already written in equation 2, equation 1 I think, yes. And I from equation 4 and theta R by 2 pi is the equation 3. But just see that the second term and third term they are same only. Pi cancel, RR cancel. So this is half A square theta dV by dt. This is also minus half A square theta dV by dt. They cancel out. So Vp is equal to Vq. So P and Q are same potential, irrespective of the angle theta. That means each point acts like a, but we know that each point acts like a micro EMF cell. That means therefore all points on the ring, irrespective of theta, are at same potential. That means electrostatic field is not there, because potential difference is 0 means between any 2 points electrostatic field must be 0, because electrostatic field can create potential difference, and potential difference between any 2 points is not there, means there is no electrostatic field between. So electrostatic field in the ring is not existing in this case. Am I clear? You must have seen this in current electricity earlier. Just I'm giving I'm going back to current electricity. Just see, this is a closed loop. I've arranged the identical cells, each having EMF E and resistance, internal resistance R. I'm connecting in a loop in an orderly manner. Total N, capital N number identical cells. Each of EMF E and internal resistance are connected in a closed loop in an orderly manner. No cell is reverse connected. Then what is the potential difference between any 2 arbitrary points P and Q? Choose any 2 arbitrary points P and Q. What is the potential difference between them? Okay, we'll start from Q to P. Okay, we'll start from Q to P, and so let us interchange. This is the Q, P, P, Q. Okay. So I start from Q to P. Current is in this manner. Okay. This point Q, this is P. So what should I see? VQ plus E minus IR plus E minus IR plus E minus IR plus that equal to VP. Let's say there are n cells in this. Total number of cells are capital A, and between Q and P there are small n number of cells. Let there be small n number of cells between them. So Q to P, with anticlockwise I am traveling. So let there be small n number of cells in between them. So VQ plus E minus IR plus E minus IR plus like nth term, we will get VP. But E minus IR is 0. Because why? Current in the whole loop is NE by NR, capital NE by capital NR, E by R. So E minus IR is 0 from equation I. Yes or no? So E minus IR 0, E minus IR 0. So VQ plus 0, 0, 0. Finally it becomes equal to VP. So VP equal to VQ. Yes or no? That means between any 2 points, potential difference is 0. Suppose you join P and Q by a passive resistor. What is a passive conductor? Passive conductor is a conductor without having any energy source, having 0 energy source, means without any net EMF. That is passive, just a rod like that. Then by a passive conductor, no current will flow through this, because at the end of the passive conductor, potential difference 0. But if you join P and Q with an active conductor means what? If P and Q I join a battery with wires, so that it becomes an active conductor. A conductor having energy source in it, like EMF cells, will be active conductor. So if an active conductor is there, then the current can flow through this, and that you have to calculate using Kirchhoff's law. And yes or no? Am I clear or not? So passive conductor, active conductor मैंने लिख दिया. अगर ये और एक मैं PQ join कर दिया with a battery, then how to find the current in this PQ branch? I have to solve the 2 loops using Kirchhoff's law. I'll find the current. But if I join a simple conductor, passive conductor, then need not write the Kirchhoff's law because I know PQ are the same potential, no potential difference. So if I join a passive conductor between them, no current can flow through this, whatever the resistance may be between P and Q. So that's it. So this I just I took a detour and went to current electricity so that you can understand this EMI also. So going back to the conducting ring in magnetic field discussion, we can join P and Q by straight conducting rod. Will current flow in it? Okay, P and Q are same potential. BP is equal to BQ, already proven. But is the PQ conductor is active or passive conductor? It is an active conductor because ENC.dl from P to Q will not be 0. Why not 0? Because already you have seen that EMF from P to Q is equal to EMF between EMF induced in this POQ triangle. Remember, BDL 111, we have discussed this. The current, the EMF induced in PQ will be EMF induced in the OPQ closed loop. So which is current area into dV by dt, which is not equal to 0. Then EMF from P to Q will not be equal to 0. So it is an active conductor. Therefore, current flows in it. We can calculate it simply by applying Kirchhoff's loop and junction law. Instead of a straight conductor like P and Q straight join, we could join P and Q by a conductor POQ. Thus, so I have given it some brown color. Where P and Q, actually this is where P and O and O and Q are two radial straight conductors. Okay, radial straight conductors. Then POQ becomes say passive conductor. भाई बताओ क्यों इसलिए passive हो जाएंगे? क्योंकि OP में कोई EMF इंड्यूस नहीं होता. वही ENC पर perpendicular to DL. Similarly, OP में भी कोई EMF इंड्यूस नहीं होगा. At every point ENC is perpendicular to DL. So from POQ, every point EMF at every point which is supposed to be a micro EMF cell, that EMF is 0. So this is a passive conductor. This radial POQ is a passive conductor. So passive conductor means there will not be any current flow if the ends of the passive conductor connected across same potential points. P and Q are same potential. If the passive conductor is connected between, the ends are connected between P and Q, then the potential difference between ends of the passive conductor is 0, so no current will flow. Passive conductor, remember, there is no energy source any point from P, O and Q, P, O to Q. Yes or no? So that's why there is no energy EMF source in anywhere on POQ conductor. There is no current flows. Therefore, it is a passive conductor. POQ because a passive conductor. ENC is perpendicular to DL if DL is radial. So therefore, ENC dot DL 0 at every point of OP and OQ conductors. There is no EMF source anywhere on the POQ conductor. So it is a passive conductor. I can write again, overemphasize basically I am doing. Let me overemphasize. Okay. It is P, O, Q is a passive conductor. Okay, so no, therefore no current flows through this. Clear? Now let us go to a very extremely important example which sometimes people ask. Let's go to the next page. Okay, well, let us go to the next page. What is the next page? चलो next page देख लेते हैं. ये लो आगे हम next page में same diagram here. Page 2. I put a voltmeter at the center. Okay, I put a voltmeter at the center. and this is the conducting ring. P and Q are 2 points. Same previous case. B and dV by dt is positive. This is there is no conducting rod here, so I need not have this line. Okay. This is the voltmeter connected to P, placed at the center of this cylindrical region, and through two straight conductors it is connected to the point P and point Q. Okay, that's what voltmeter resistance in the voltmeter is RV is placed at the center and they connected to P and Q by two straight wires of negligible resistance. Okay, I will come to the why negligible resistance in the next situation. What is the reading of the voltmeter? What reading correct? Simple answer. Since I discussed above in the page 1, the wires are radial, no current flows through them. Therefore, the current reading becomes very simple answer. Whether radial, so this becomes a passive conductor. So and PQ are same potential, so no current will flow through POQ. This is so. This will be reading will be 0. Now the voltmeter V is not placed at the center. It placed here so that the two conducting wires are connecting P and Q in a straight line. Yes or no? And the resistance of the conducting wire is 0. B resistance is RV. तो अभी बताओ क्या रीडिंग होगा? आंसर देखते हैं. What is the reading of the voltmeter? The question is the straight wire. आंसर देखेंगे. Straight wire are no longer passive. They become active, as I discussed earlier, first page. So, what will I do? I'll apply Kirchhoff's law. Let's say the total current in this ring is capital I. Out of that, small I flows through the voltmeter branch, and capital I minus small I flows through this PQ branch. Okay, then what is this area? The sector area is half S square theta, and this triangle area is half S square sine theta. So this area will be difference of these two. Okay, remember this. So first, going in the outer loop, what I should find? The Kirchhoff's loop, Kirchhoff's law I am applying to the one loop is complete outer loop here. Okay. Total EMF is pi S square dV by dt. But the potential drop, capital I into R of this much section. This much section, what is the R? If total resistance is capital R, then this angle is 2 pi minus theta. Yes or no? So this angle will be 2 pi minus theta. This angle will be 2 pi minus theta. 2 pi minus theta. Yes or no? This is 2 pi minus theta. So, what is the resistance of that part? R in total resistance into 2 pi minus theta by 2 pi into I. That is the IR drop from here to here. So, similarly, what is IR drop from here to here? The capital I minus small I, and this resistance is theta by 2 pi into capital. मैं लिखा कि नहीं? I minus I into theta by 2 pi into capital R. This much IR drop in the PQ. This much IR drop in the bigger PQ. So this is EMF minus voltage is 0. I'm back to the same point in a loop. So if I rearrange this, I get this equation. From here, I get equation this. Okay. Now another loop I have to go. That is this small loop. What is the EMF induced in this small loop and in the closed loop? This area enclosed into dV by dt. This area into dV by dt. Did I write that? Yes, this area into dV by dt. So what is the IR drop here? I minus I into what is the resistance of this part? r theta by 2 pi. So I minus small I into r theta by 2 pi. Then I'll be going Q to P to complete the loop. But I'm going opposite to the small I direction. I'll make plus I into RV. Plus small I into RV. I did that is equal to 0. Then rearrange. I got this. So equation 2, equation 1, I small I, equation 2 also I small I, coefficients are different, and this right answer. So what is my aim? Small I into RV. So capital I eliminate. How to eliminate? Multiply equation 1 by theta by 2 pi and subtract equation 2 from this. That's it. So capital I will be eliminated. I get small I into RV plus r theta by 2 pi minus r theta by 2 pi square. This I multiply theta by 2 pi and subtracting equation 2 from there. So I RV plus r theta by 2 pi minus I r theta by 2 pi square. Then whatever theta by 2 pi if I multiply, I get right hand side this. Multiply theta by 2 pi. So pi cancel. So half a square theta into dv by dt minus half a square theta minus sin theta dv by dt. So remaining is this. Half a square sin theta dv by dt. So what is the I? Small I. This. So what is voltmeter reading? Small I into RV. Small I into RV is the potential difference across V mean, that is reading of voltmeter. So this is the voltmeter. That's it. The values of RV, capital R, radius, theta, rate of change of magnetic field is given. You can find the numerically that value. Okay, this is the voltmeter reading will be equal to IRB equal to this. है ना? Am I clear? So now are you clear? Slowly, step by step, your concept must be building up. Now you can confidently attempt these cases. So I think if you need to go through again, then go through twice, thrice if you want to, but go through my previous VDL 110 and 111 if I missed them. If you understood them, this is nothing but you can understand. It is very nothing but highly understandable, no problem. So slowly I'll change that ring to a non-homogeneous ring and see what questions can be asked. So that is next lecture. Are you understanding this? क्या भाई कुछ बताइए. In case of any difficulty, you can contact me. I think all of you are aware of my credentials. ये लो पेज 1 में हमने लिख रखा है शुरू से. These my credentials. You can always contact me in case of difficulty or whatsoever difficulty you are having, whatever personal doubts you are having, you can contact me. But refer to my previous lectures. I'll be always there for you in case I'm able to help. Okay. All the best. Have a good day. We'll meet very soon with the next sequence, lecture 4. Okay. Thank you all.